I mean, there are several things here. There is the politics. There is the intelligence stuff, CIA type stuff, the black ops stuff, and there's the physics. And I have things to say on all that, because I'm a firsthand, I'm right in the thick of it, so to speak, and have been for 70 years. That's what I want to point out. This started when I was a kid, man. And in fact, I can even go back to when I was 4 or 5 years old. Really weird shit. Okay, so I've been involved with this my entire life. All right, and there's a paranormal component. There's what Jacques Vallée calls high strangeness. That's very much a part of what's going on, and it's very much a part of what's happening right now with all this Pentagon stuff. And the Russians, don't forget the Russians and the Israelis, and all the intelligence features. But let's see if I can get my. I want to see now. How did we get back to the? I want to get my iPad so I can draw. Now I am ready for anything. So Nick, if you want to duel, we can duel.
And
I got my trusty. The Apple Pencil is mightier than the sword.
I'm not sure if Nick is still on.
I see him.
Oh, okay.
Okay, Nick, I'm gonna duel. We're gonna duel with the get your Apple Pencil, Nick. The Apple Pencil is mightier than the sword. Okay, go ahead. I'll stop fooling around. All right, go ahead. What's happening?
Oh no, it's up to you, sir. So yeah, you mentioned you wanting to draw on the screen to equations and stuff like that. So we have you spotlighted. You're on the kind of the right-hand corner, and then it's actually showing your iPad screen. So
yeah, right. Well, I'm waiting now for questions.
Oh, okay. Well, yeah, absolutely. So let me start with Jeremy Reese. Jeremy?
I don't see him. Is he here?
I'm here now. I just had to unmute. Jack, I had a question. You mentioned John Archibald Wheeler's involvement with a lot of the theoretical research into some of the stuff back in the 50s and stuff. Yeah. And also Froelich going back to the 30s even and stuff. Do you think it's possible that any kind of faction of the scientific community figured some of this stuff out?
No,
before?
it's not. No, it's not. It's not possible. Well, let me first say something about Wheeler. Okay. I think Wheeler's cousin was General Earl Wheeler, if I'm not mistaken, who was at the time the head of the Air Force. Okay. And I also know that was it Kurt LeMay? We have from when we were at when Joe Firmage in 1999 set up this ISSO. There was a guy, one of our scientists, and you could his father was a friend of Kurt LeMay. This is a story we got, okay? And so he's a little kid, and Kurt LeMay would come over to his father. His father was an Air Force guy, a strategic air command guy. And Kurt LeMay would come over with these videos, with these film strips. They would go down the basement and play, and they were UFO encounter films. Are you there? Can you hear me? Is everybody hearing what I'm saying?
Yeah, okay. I can hear you. I think Jeremy muted himself back out so he wouldn't disrupt.
Okay. All right. So, any case, so Curtis LeMay was showing these flying saucer films to a group of officers, including this guy's father, in our friend's house, and he would watch these films. He's a little kid, they don't watch. Okay, that's how he got interested in UFOs. What happened here? Oh, I see what happened. Okay, nothing happened. All right. So now, but the point I wanted to make though was that up until 1952 or so, Wheeler's main work at Princeton was nuclear physics. Okay, and what I think happened, I know, this is now I'm guessing, educated guessing. What I think happened was that Earl Wheeler read John Wheeler in on all this stuff that was going on, and that's why John Wheeler shifted rather abruptly and dramatically from his work in nuclear physics to general relativity. And that created the whole revolution in general relativity, which was really created by Wheeler and his students, in particular Kip Thorne. Okay. And so
Didn't
what-
Wheeler also get into metallurgy really heavily? He was
Wheeler originally was a chemical engineer. He was a metal. He started school. He started out as a chemical engineer.
yeah.
That's why that's why Wheeler in the Manhattan Project, he was in charge of Oak Ridge, all that chemistry.
Yeah.
Chemistry, because that was his original background.
And also, what about Mills Purcell? So his theories started like the whole revolution in nuclear magnetic resonance, which led to the development of metamaterials.
I don't see. You may know something I don't know. I don't know that Purcell at Harvard, right? He was at Harvard, right?
I believe, yeah.
Harvard. That led to metamaterials? Maybe. I don't know. I don't know enough.
He headed the CIA's Project Rainbow, which was all the invisibility stuff back in.
Oh yeah. Okay. Yes. Yeah. I see what you're getting to. Right. I gotta do this again.
Yeah, so I didn't know, like his research seemed interesting and stuff. I just didn't know.
Okay, but here's.
And what about as far as metamaterials? Do you know of any companies that are producing these or anything like that nowadays that are trying to do these?
No, I don't. I'm saying, remember there's been COVID, so we've been virtual quarantine. I only see what I see on the internet. What guys like Art Wagner, who goes through the literature, send to me. And remember, I'm not a metamaterial physicist. I'm not a solid state physicist. But Keith Wanzer is more along those lines. He's a real expert. He does experimental and theoretical physics in that area. So he's the guy. I want to try to get this again. So what happened?
I know there's a company in Dartmouth, Nova Scotia called Metamaterials Incorporated, and they have a lot of optics and solid state guys who work on developing metamaterials. I don't know. They don't reveal much about any products or any kind of thing that they're developing, though.
Okay.
Yeah, and it looks like there we go. Yeah, it looks like it's woken back up for you, Jack.
Yeah, it happens every now and then because the thing goes, the power's down. All right, so, okay, so Jeremy, any more questions about that?
Yeah, I was just trying to think of, if there's any way that someone could have produced some kind of material before that.
Well,
it just doesn't seem.
See, here's the thing. See, these guys pissed me off. Hal Puthoff, who is a good guy, and especially Eric Davis, they pissed me off because they throw up all this national security. It's classified. They're keeping everything secret because they're hiding their own ignorance. The only important thing that Eric Davis has said, that the alleged retrieved material, right, has metamaterial lattices down to an angstrom. That's like the size of a hydrogen atom, right? So there's no way, none of the metamaterial guys are working, they're doing like inches, they're doing acoustic inches, maybe microns, and maybe nano. I don't know if they're down to nanometers yet, maybe. But that's what the new Manhattan project that I'm calling for would be.
I had heard that they were doing high temperature, high pressure hydrogen crystals is what they were using.
Yeah, but that's clearly, that's so what? I mean, the Tic Tac, the flying saucers, they're not using high pressure materials. I mean, right? They're using something that's operating under regular pressure in the atmosphere. So.
Yeah,
okay.
You wouldn't be able to contain the pressure on that if it's a surface.
No, it has nothing to do with that. That's a barking up the wrong tree altogether. Okay, there's something. What we need is we need these dozens, maybe hundreds of solid state guys, nanotechnologist guys, computer simulation guys. We need the kind of computer facilities that Kip Thorne used when he did the black hole collisions, the gravity waves coming from black hole collisions and neutron stars and the Interstellar movie. You need that kind of computing power to simulate, And then now I do know this, that there are now artificial intelligence programs that are actually designing metamaterials, but probably within probably not down at the angstrom level, but micron and stuff like that. So artificial intelligence is going to play a role. And when I say artificial intelligence, I mean just ordinary artificial intelligence. I'm not talking about the conscious artificial intelligence that I'm also working on. It's a separate thing. All right. So is anybody else?
Oh yeah, actually, Jack. So
Hello.
the next one that we had, well, Jeremy, let me come back to you in a bit.
Hello, saya Suparmo Jam.
I'm sorry about that. That was yeah.
Thank you, Jack.
Okay.
Thank you, Jeremy. So let me go next to, let me see. Let me go next to Christopher Plain. Okay. Sorry about that. I'm gonna change that a little bit there. Okay. So Christopher, he was asking about, let me see, and I just muted out that individual. I'm not sure who that was. Christopher, let me unmute you. He was asking about how far in the future Jack thinks Tic-Tac pilots are from.
Well, I don't know. That's a good question. I can tell, all I have is hearsay. I could just, okay, now we're getting into the eye strangeness. Okay, this is pure. Okay, let me, what is Wheeler talks about, you know, there are a few iron posts of observation in the paper mache of theoretical speculation, okay? All I know is this, when I was a kid, when I was 13 or so, I had a contact with a Tic-Tac. I didn't call it a Tic-Tac then, you know, now in hindsight, I know it was a Tic-Tac. And I'm not gonna go spend too much time on the story, but all they said they were from the future. They told me they were from the future.
Telepathically?
What? No.
Oh,
Using a voice or telepathically?
Not
sorry,
telepathically. Not telepath. No, this was on a phone call. This is a whole story. This has been written about many places. This was a series of phone calls I got on the telephone with a cold metallic voice that sounded exactly like Stephen Hawking's voice later on. Okay. This is called, and this is a voice also that my mother finally grabbed the phone and she heard, she talked to it too. Okay. So I wasn't imagining it. And they said it was a conscious computer on board a spacecraft from the future. This was 1953. And they said I would begin to meet the others they had selected in 20 years. 20 years goes by, it's 1973. And I'm suddenly, by a very set of strange circumstances, I wind up at Stanford Research Institute with Hal Puthoff, Russell Togg, Brendan O'Regan, Edgar Mitchell, Dean Brown, a whole bunch of people, other people I can't remember who they were. And some of that, it's a CIA thing. And some of that CIA recording is actually on the internet. You can hear it. You can hear us talking about UFOs in the future in 1973. I talk about my phone call back in 1953. 20 years, you know, on cue.
Wow.
Okay, that's important. See, people are so stupid. I mean, yeah, what you need is to be like, I'm like a cop. I'm doing forensic now. I'm not only doing physics here. I'm like a homicide. I'm like, you know, Inspector Clouseau. Right? I'm almost like, hey, we got like, there's a crime going on here. We got these clues. Okay. Also, and let me say this. There's this guy, Paul Hill. Back in the 50s, he wrote a book called Unidentified Flying Objects. And when he did a forensic, he took information that he had. He was part of what was the pre-NASA, I forget what they called it. And he tried to figure out how to explain the observations they had there. And to his credit, he kind of figured out it had to be like a warp drive. But this is 1953. He didn't know any general relativity. He was an engineer. He was a good aeronautical engineer. He only knew about motion, things moving through space. He didn't know about warping space. But he came up with a concept called acceleration fields, which is basically warp drive. And he did that by pure empirical inference. You know, like Faraday. You know, like Faraday doing lines of force. You know, things like that. Humphrey Davy, empirical stuff. But I'm sort of doing that here too. Except I know some general relativity. I'm taking the information, the clues, and that includes my high strangest contact through the telephone which apparently happened over 3 or 4 weeks, though I only remember the first phone call. It's a whole, there's a missing time. It's classic UFO abduction stuff, okay? Missing time, all that stuff. You know, that John Mack was investigating and people like that. We have to.
And you were going to tie this back to a time you thought the potential time in the future where these
Yeah, so,
attacks
okay.
weren't-
Yeah, and actually, let me, Christopher, if it's okay, let me ask you to turn your camera on, sir.
I'm at the wrong computer right now, Tim.
Oh,
I'm so
okay.
sorry.
Yeah, no
that's
worries.
why
All right,
when I
let me give,
scream in with you guys, I usually don't have my camera on. I'm
okay,
sorry.
let me give you a number. Let me give you a number. I'm gonna give you a number, 100 years.
Okay.
Let me tell you why. Let me, no, you know, that's just, I'm gonna tell you why I gave, where that number comes from. You know, I'm not making it up. So this would have been, so how many years ago is this now? This would have been, let's see, in the 1970s, was it? Yeah, like 1973, 74. So that's about 50 years ago. What happened was at SRI, they were doing experiments with not Pat Price, Ingo Swann, okay, the psychic Ingo Swann.
Mhm.
This is a story that Saul Paul Sirag told me through his girlfriend at the time, Barbara Honegger. And this was at the Henry Dakin, now dead. This was at Henry Dakin's Paranormal Laboratory on Washington Street, where Saul Paul Sirag was actually living there with Barbara up in Presidio Heights. And Brendan O'Regan came over, and Brendan O'Regan, he was the liaison between Stanford Research Institute, the CIA, and Edgar Mitchell. He was kind of Edgar Mitchell's Man Friday. And well, the story goes that they were doing remote viewing experiments on Ingo Swann. Get this now, okay? Ingo Swann goes into a trance. He's a trance medium type guy. He starts speaking in a cold, metallic computer voice.
And this is 20 years after your phone call.
Yeah, 20 years
Series
after
of
my phone
phone
call. Yeah, 20 years after my phone call. The same kind of metallic voice that I heard, okay, as 20 years before. This was maybe in 1974. So you have to talk to Saul Paul Sirag and Barbara Honegger if she's still alive. If Saul Paul, I don't know if Saul Paul, he's not senile by now. but and it said it was 100 years from the future back then. So it would be 50 years from, roughly 50 years from us.
Interesting. Thank you. I had put one other question in the chat, Tim. It was about the connection between consciousness and UAP.
Yeah.
And is that just a more or less like a Hal put off Jacques Vallée sort of theory, or do you have your own?
No, not my own
working
theory.
belief?
No. We all agree about this roughly. No. It turns out the physics of UFO propulsion and the physics of consciousness generation are two sides of the same coin. They're closely connected, mathematically speaking.
Ah,
It has to do with the Froelich. It has to do with the Froelich condensate effect. Okay, you have to go to Hameroff. Stuart Hameroff says that the microtubules are where consciousness is generated.
sure.
Us,
That's
right?
pretty recent, but yes.
Yeah, okay. Now there's this other thing, whether he's working with Roger Penrose with gravity collapse. I'm not going to talk gravity collapse right now. That's a whole other issue. The exact mechanism, how that happens, but the idea that consciousness is generated in the microtubules is like an empirical thing that caused Hameroff to think of it. And I think that was a valid insight. I agree. I agree with Hameroff on the empirics that I think it's most likely that that's where our consciousness is generated. And guess what? Microtubules are metamaterials. They're natural metamaterials. They're tubular metamaterials. Electric microtubules. Okay, so the metamaterial, and they're pumped. They're pumped, and there's a lot of controversy whether they were Froelich condensate. I mean, basically, the picture is this: what a Froelich condensate is in a pump system, it's sort of like a laser. A laser, it's an unequal. See, here's the thing: what they are, they're room temperature superconductors and superfluids, but they're non-equilibrium. They only exist. They're emergent only when the power when the energy flow input is above a certain critical threshold. It's like the critical threshold for lasing. It's very analogous to a laser. Laser is a non-equilibrium open pump system, as opposed to the superconductors and the Josephson effect, which are thermodynamic equilibrium, the Cooper pairs and all that stuff. That's an equilibrium. But what I'm claiming, there's a lot of claims here. There's a lot of technology here. I'm claiming that everybody's been very stupid for the last 70 years. They've been trying to get high temperature superconductors, but the schmucks, what they're doing, they're keeping everything in thermodynamic equilibrium, lowering the temperature with cryogenics. I'm claiming you get superconductors at room temperature and even higher temperature by pumping the systems resonantly into these fuller coherent states. And like in the metamaterials, in any material solid state system, you have what are called quasi-particles. And there are all kinds of quasi-particles. Some of the quasi-particles that are induced have charges like Cooper pairs. They have polar autons, all kinds of stuff. So what I'm claiming is that if you pump the stuff, you get into this coherent state, and that amplifies the coupling between electromagnetism and gravity, and at the same time generates consciousness. So it's a conscious computer. The conscious computer is built in to the metamaterial fuselage. It's both. It's a conscious. It's like a living entity kind of, but it's on It's
Interesting.
a solid state. It's a solid state. Like John Lilly used to talk about these solid state, and it's a solid state entity like John Lilly. It's conscious, but it also can it propels it. It goes. It warps space time. It controls space time, and it's conscious. So it's the command, control, communication, navigation system of the device. Now there may be living creatures inside, but you don't need them. They're kind of redundant. Maybe the grays, little grays.
Yeah, but you're saying the material is inherently conscious due to this method.
Yeah, but it has to be, because that's the only way. You see, it requires a quantum hyper. Okay, no, wait, computers. Let's say a few words about computers. You got classical computers, right? The computers, these are classical computers, right? And they're described by Turing machines. Turing machine, you read
Yep,
Roger
sure.
Penrose, Shadows of the Mind, The Emperors of the Mind. So what is a Turing machine? Turing machine is basically, it's a tape, it's like a tape head. And then, it's the squares. The tape moves one cell at a time, but only moves forward in time, right? Any algorithm is a set of rules that moves one way forward in time. Okay, okay. Quantum computers are different though. Quantum computers, because of entanglement, and now like Nick Herbert likes to talk about entanglement, but Nick and all these guys, as far as I can tell, Nick only knows really about orthodox quantum theory, the von Neumann projection operator, what are called strong measurements. I'm not sure Nick can correct me if I'm wrong, but I'm not sure if Nick ever really read carefully Yakir Aharonov's idea of weak measurements. And the weak measurements is a finer, it's a more subtle kind of measurement. And it's like the strong measurements of von Neumann are like a zip file of the weak measurements. And in the weak measurements, you read Yakir Aharonov's papers, the weak measurements, it involves entanglement is explained as back from the future influences. In other words, the final measurements actually act back on the creation of the event. So these time loops, that's this whole kind of thing that I'm talking about in general terms. What do you call it? The Yakir Aharonov, actually back in 1964, he first did the papers, Aharonov, who was a student of David Bohm's, by the way.
Proposing that backwards effect in time.
Yeah, and now this whole idea of Aharonov has been resurrected and sort of done in a more popular way by a guy named Huey Price. Huey Price is the Bertrand Russell Professor of Philosophy and Physics at Trinity College, Cambridge. And he has written in the last few years, explaining how entanglement, how non-local entanglement is really locally retrocausal, and it's consistent with relativity. And by the way, the first guy who saw, actually, it was really what this is. It all goes back to the Wheel of Feynman classical electrodynamics in 1940, and it goes back even before that. A guy named Stuckelberg had it. So it's been floating in the air from the very beginning of 20th century physics, various versions of it. And and actually, Fred Hoyle was also into it. Fred Hoyle in 1983 or so wrote a book called The Intelligent Universe, where he has that information's going back from the future. And it's also involved in the Feynman path integral, because, okay, whenever you have a Lagrangian interpretation, Lagrangians are global, and really the Lagrangian involves influences from the future and the past. In fact, if you look at Feynman's original paper on 1947 in Reviews of Modern Physics on, I think it was non-relativistic quantum mechanics from his point of view, he has two different wave functions. He has a wave function coming back from the future, and he has a separate wave function coming from the past. So you have the present, you have a wave function coming back from the future to the present, and he has a separate independent wave function coming from the past to the present. The two of them, they meet at the middle. They meet at the present. The two separate wave functions, they each have their own complex conjugates. Okay, and that's what. So that's what must have motivated Aharonov. Obviously read Feynman, and he built up a whole thing with weak measurements. See, Feynman didn't go into weak measurements, so there's a whole bunch of stuff. And the weak measurements are actually of practical laboratory importance, because there's this guy Ephraim Steinberg, who was doing all kinds of like practical, optical. They're measuring stuff that you can't measure normally. So weak measurements, it's a practical engineering. It's not just theoretical. It has practical implications. And Huey Price from Cambridge in the last 5 years or so has shown how to understand entanglement in terms of these, what are called coast. See, oh yeah, there's Costa de Beauregard. Okay, this is interesting too. Costa de Beauregard is a French physicist connected with the Institut Henri Poincaré, with Vigier and de Broglie. These are all like students of de Broglie. Broglie, okay. And Costa de Beauregard, he was also involved in all this paranormal stuff. In fact, I'm pretty sure Costa de Beauregard visited Put-Off and Targ at SRI around the same time I was there. Anyway, so I forget how I met Costa de Beauregard, but I spent a couple of days with Costa de Beauregard when I was there with Fred Allen Wolf in '66 at the Institut Henri Poincaré. And it was like Parsifal, because I was so stupid, because I was like Nick. I was dumb like Nick, because I was into all the Wheeler and the collapse, and Niels Bohr and Heisenberg, potentia into actua, and and Costa de Beauregard, he was trying to explain all this stuff to me, like a dumb idiot I was back then. I sort of didn't get it. It was there in my subconscious. I sort of, part of me got it, But I was exposed to these ideas back then, and kind of slipped by me. I'm too stupid to get. So Costa de Beauregard knew what he was talking about. He was right. And now, okay, but let me bring you up to date. So there's all this stuff going on already back, the beginning of quantum theory. Yaakov Aharonov calls this. He says he has two wave functions: the destiny wave function, which is back from the future, destiny and history. And the two things meet together. It's a weak measurement, okay? And now, if you throw away all the information from the future, you get the ordinary strong measurement. You get what Nick Herbert likes to talk about, and what that's the von Neumann theory. So you get back to von Neumann theory is a limiting case of the weak coupling. The weak measurement theory is a more general quantum mechanics. It's a finer structure to the quantum theory. It's consistent with the orthodox theory. And if you throw away information from the weak measurements, you'll get the strong measure. You'll get exactly what Henry Stapp doesn't do weak measurement. He does everything he does in his theory of consciousness. It's all strong measurements. Stanley Klein, all these guys, they don't know about Aharonov. Okay, but now what's even more important. In 2015, there's this guy, Roderick Sutherland. Okay. Sutherland, he was a physics professor in Sydney. And fortunately, he made a lot of money on the stock market. So he became independently wealthy about 20 years ago. And he just maintained his his status, he took an early retirement, like emeritus professor at the University of Sydney. And he's able to do whatever he wants to do, to follow his, and of course he's into boom. So what Sutherland has done, there's a whole series of papers, Roderick Sutherland on the archive, you get his papers, they're very good. And he took Bohm's 1952 pilot wave theory, okay?
Yep.
Variables, which, had a problem because it needs configuration space, for entanglement, it gets very complicated, and it's inherently non-relativistic. And he showed, so what Sutherland did is he synthesized Yaki Aharonov's weak measurement theory, which is fully relativistic, weak measurements, fully relative, it's a Lagrangian thing, fully relativistic, it's manifestly covariant, no problems with relativity, even with entanglement. And he showed how to couple it into Bohm's picture, okay? So it's the Bohm, and it's this ontological picture, realistic picture, that there really are particles moving in continuous classical trajectories, the Bohm quantum potential, but everything is now relativistic because everything is done in terms of weak measurements, basically, okay? But he also includes action-reaction. What does that mean? See, the terms action-reaction in Copenhagen interpretation doesn't mean anything, because people like Nick, who's a Copenhagenist, basically, they say, and who's this guy? He died. There was some famous Israeli guy, a good physicist, I forget his name at the moment. They said, the wave function is the complete description of quantum reality. The wave function, complete description of quantum reality. So as soon as you do that, you throw the baby out with the bathwater. There's no classical, and then you have what's called a reality problem. There's a problem, there's a problem with classical, how does the classical limit emerge, decoherence, all this bullshit, all this stuff you see. They threw half the problem out. And so the point is this, what David Bohm and Hiley, if you read David Bohm's later works, and if you read some Basil Hiley stuff, orthodox quantum mechanics, in which you have what's called no signaling, right? You cannot use entanglement as a direct superluminal or back, even retrocausal command control communication system, because what happens is you have to have, in order to, suppose you want to encode a message on entanglement, in the entangled wave function. You can do that, you can encode the message. But in order to decode it, you have to have a classical key. In fact, this is the whole idea of quantum cryptography, is based on this notion. And that's what you read David Kaiser's book, he describes this whole thing, okay? And Nick Herbert actually has a good way of describing. He says, you cannot, I think Nick says you cannot locally decode the entanglement signaling. You need this classical key, okay?
Yep.
Now, get this now. What Bohm showed is that the reason for that, the reason for the no cloning theorem, the reason that you cannot use, the reason that's the quantum noise is uncontrollably random and locally cancels out any information at one end of the system without information in the classical signal coming from the other end of the system. The reason for that is that in quantum mechanics, the wave function in the Bohm picture, let's say, the wave function, what we call the Bohm quantum potential, it's a physically real field that changes the classical motion of the particle, okay? So what happens is the quantum field, the quantum information field, the Bohm potential, the Q field, okay? It's a physical field. It changes the classical motion of the particle. So the quantum wave function acts on the particle, but there's no direct reaction of the particle back on the wave function. And if you assume that, then you get the no signaling theorems. That's conventional quantum mechanics.
Yep.
What does that sound like? That's exactly the situation in classical relativity. Because in classical relativity, what happened in 1905 in special relativity, from the modern point of view, is that space-time acts on matter, but there's no direct reaction of matter back on space-time in special relativity theory. That is, there's no gravity. And what does that mean? What does it mean for space-time? Now we're going to get back to geodesics. what does it mean for space-time to act on matter? It means that if you have a neutral test particle in flat space-time, out in the sticks away from all masses, it means that the time-like geodesic, the natural motion of a neutral test particle will be in a Euclidean straight line at constant velocity relative to anybody else. Okay, that's what that means. It means no gravity. So, but what Einstein, it took Einstein 10 years of struggle, 1905, 1915 or so. He had he had to learn tensor calculus. Right? He had this Marcel Grossman, his friend who was a mathematician, show him how to do tensor calculus, and he struggled. He was fighting David Hilbert, who was a good mathematician, got there a little bit before him. He was struggling to get these tensor equations. Okay, but the key thing, there were two physical ideas in general relativity. What is the equivalence principle, which we'll have to get into, the equivalence principle, what that means. That actually it's pretty complicated what it really means. It has several levels of meaning. You have to get into that because it's relevant to the warp drive issue. But there's also the idea that space-time was, in special relativity, the space-time is infinitely stiff. You can't bend it at all. Because especially it's as if the speed of light is infinite. Okay, in a way. You can't bend it at all. It requires infinite energy to bend it. Okay, so Einstein finally realized that with the stress energy tensor, you could bend space-time. But even the way general relativity is today, it's not as stiff, it's not infinitely stiff, but it's still pretty damn stiff. It's so stiff that you can't do anything fun. You can't have fun with it. You can't be like Q in Star Trek, except now we can. That's what the flying saucers are. See, the flying saucers are low power warp drive technology with being controlled and computed by the conscious AI. Okay, now I have to get back. I stopped explaining something. There is what's called, now we're talking about this classical computers. Turing machines that the tape moves only one way in time, forward in time. Then you have kind of like quantum computers, and in the weak measurement sense, there's some backward in time influence in the quantum, using entanglement as a resource. That's a backward in time, and you can sort of do things with quantum computers that you cannot do with classical computers. And our whole quantum cryptography technology is based on that. I call that the Maginot line. That's the new Maginot line. They think it can't be hacked. It can be hacked. It can. It's not as secure as they think it is.
Yeah, just like the original.
Wait, because let me tell you why. Because
we're dealing with natural particles.
No, forget that. I'll tell you why. The reason is because there's something called hypercomputation. Well, I call it post-quantum computation. There's classical physics, there's quantum physics, and now there's quantum physics. In the same way, there is non-relativistic mechanics, there's special relativistic mechanics, and there's general relativistic mechanics. And the transition from special relativistic mechanics to general relativistic mechanics is the same conceptually as the transition from quantum mechanics to post-quantum mechanics. It's the restoration of this generalized action-reaction principle. It goes two ways. So now what? There's a guy named Seth Lloyd, and there's a couple of guys. It's not just Seth. Actually, it was David Deutsch. I think David Deutsch. Yeah, David Deutsch had this too, but they have like different versions. They said, suppose there's time travel. Suppose you're able to go back, the loops in time. Closed causal, in general relativity, you have what are called these closed time-like loops. We can literally send particles back in time. Okay, without violating anything, without violating general relativity. Locally, special relativity is obeyed. This is kosher. This is and what they're able to show is that if you have a computer, a quantum computer, that also has like a little wormhole in it, has some kind of a time machine in it, that's called hypercomputation. Okay, and what I'm saying is there's a connection. The action and reaction in the quantum theory corresponds to closed time-like loops in general relativity, and you have this hyper computation capability. You can do all kinds of stuff they can't even do with quantum computers. In particular, you can hack the regular quantum cryptography, you can hack that. And these are papered by Seth Lloyd. He shows all this stuff, okay? Shows what you can do if you can actually send particles back through a traversable wormhole, back in time. You can do all kinds of new amazing things. And I also claim that's what you need for consciousness. In fact, in our consciousness, we're effectively doing that. Because what he shows is that, see, with action and, gets into this. You heard of Lenny Susskind, ER equals EPR. There's a kind of duality that that EPR entanglement connects with Einstein-Rosen wormholes. This has to do with holography, the whole holography idea. Now, if you go back to my book, my comic book with Fred Wolf and Bob Tobin, this crazy comic that we wrote stoned in Paris at the Café du Magot, not knowing what the fuck we were talking about. We're channeling, a lot of stupid stuff in that book too. But in that book, I have in the original, Dutton edition, there's a whole story there having to do with Ira Einhorn. Well, in any case, there's a whole other side story there. But in that book, I have ER equals EPR, 1974, 1975, before Lenny Susskind even heard of it. And Lenny and I used to work together a little bit at Cornell in 1963, which is another synchronicity. Everything's connected. A lot of Jungian synchronicity. I had ER equal EPR, but I had it as traversable wormholes in which signals can get through, creating consciousness. I had all that back in 1975. And where did I get it from? I don't know where. I got it because the Tic Tac, because they're talking to me from the future. They're telling me, these ideas are being implanted in myself and they're coming out. I had all that.
Great. Hey, Dr. Jack, thank you for bringing that full circle for me back to the consciousness and the UAP. That is the only question I have left. Tim, I'm going to hand it back to you here.
Okay, well, and thank you so much, Christopher. Okay, so let me mute him out. Okay, and then